Again. So today's video is Cube-n-ometry Worksheet, and this was your homework. We'll start with number 1. Draw the views and the grids below for the following three-dimensional block figures. So they give us a nice little picture here, and we are going to draw the front, top, and side view of this figure. Alright, so let's begin. Remember, when we're looking for the front view, it's what is facing us. So these three in the first column are facing us. So we're going to draw here, here, and here. We have 2 in this column right beside it, so we're going to color in these 2. That's all we have for our front view. For our top view, remember you want to look down on the figure, right? So you want to look down. So we have this guy on top and this guy, and that's it. So we're going to put 2 right beside each other, these 2. And then finally for our side view, we're going to go around the block, and anything that faces us in this direction will be our side view. And this is actually going to be 3 blocks tall. So we come over here, and our side view is 1, 2, 3, just like that. Okay, I'm gonna skip over here to number 3 since it's all on one page, make life easy, and we'll do the top, the front, the top, and the side view of this figure over here. Alright, so let's go up here and we will change our colors. Okay, front view is what is facing us. So we have 3 blocks here. Ready? 1, 2, 3. In the second column we have 1. And in the third column we have 1 more. So it's like a nice little L shape right there. Alright. Our top view is going to be, if we can stand above the blocks and look down, we have 2 in the first column. So I'm going to come down here and put 2. We have 2 in the second column. And then we have 1 in this third column by itself. Okay, so if you can look at it, 1, 2, 3 on the bottom and 2 above it. 3 on the bottom, 2 above it. Excellent. Alright, and then finally for our side view, we want to look at what we can see if we stand over in this direction. So we have 1 here, here, and here. So we have 3 in our first set. Okay, and then be very careful because there's 1 hiding here. We have this one, and we have these 2 above it. So we're going to have 3 in our second block as well, in our second column over here. Okay, make sure you color those in, shade them in, and that is how you do the shading to go from 3-dimensional to 2-dimensional. Pause the video, make sure you have all yours shaded in. Or if you've already done this and you're just checking it, make sure yours matches mine. Alright, I'm going to go ahead and clear this out. And then we're going to scroll down to the second question, which is using the figures and views above, what would be the surface area for this figure? 1 centimeter is a cube. Alright, so surface area for this is going to be hard because we can't change our blocks, right? So we're going to have to visualize in our mind how many faces we see. Because remember, surface area is all about the surface. What can we touch with our fingers? So to try and make life a little easier, I'm going to count them. So we have 1, 2, 3, 4, 5, 6, 7. We have 8, 9, and 10. But be very careful. It's not just what you can see here, because we have the back sides of all these cubes too. And if you're going to wrap a present, right? Surface area is about wrapping things or covering things. If you're going to wrap this, you don't just wrap this front part, you got to wrap what's behind it too. So even though we have 10 here, we've got things on the side and behind it. So we have 10 we can see. Now, on this side, we have another one right here, and right here, right? The side pieces of these 3 cubes. So that's 11, 12, 13. And then we have the bottom pieces, 14, 15. And now we can look at the back of this. So on the back of this cube, right back here, I'm going to have 16. On the back side of this cube, right, so if you can see it, on the back side of the second cube is 17. And then on the back side of this last cube here, you know what, to make life easier, I make this small so I don't erase everything. I'm going to put this guy over here. So on the back side of this guy, that's going to be our 17. And on the back side of this guy is going to be our 18. Then if we look on the back of here, we have 19. And if we look on the back of this one, actually we have 20, yeah. We already counted the bottom. So it looks like we should have 20. Let's double check our work, make sure we're right. Another way you could do this is count all the sides of each block as you go. So I'll show you how we can do that. So watch. 1, 2, 3. The back side makes 4. This side makes 5. Okay? So I could say I have 5 for the first block. And you look at this block, I have 1, 2, and 1 on the back is 3. The same thing, let's see. Well, this actually would be 1, 2, the back side would be 3, the bottom would be 4. 1, 2, 3, back side makes 4 on this guy. And then for our last cube, we have 1, 2, 3, and the back side makes 4. So you can count up all the faces individually like we did in red, or you can count each face for each cube and then add them up. So that would be 8, and then 8 plus 4 is 12. 12 plus 4 is 16, and 16 plus 4, oh look, I got 20 again. That's awesome sauce. So I have 20 and 20. Now, to make sure, let's scroll back down here. Do they have 20 as an answer? And they do, look, right there, C. Very cool. So there's my answer, C. Makes sense? Did you guys see how I did that? Well, let me erase this, and we'll go back up and make sure you got that. So if we scroll back up here, here we go. So just make sure you count all the faces. Okay, surface area is about counting all the faces. Now next week when we get into surface area of different shapes, like prisms and cylinders and things, we'll have formulas, so it'll be a little bit easier. But this is just to help you understand what surface area is really all about. So I'm going to clear this out. And oh, before I clear it out, this is a good way to show work for number 2, is just labeling your sides, either adding them up or actually writing the numbers down. Okay, let's look at what number 4 says. All right, using the figure and views above, what would be the volume? So there's your key word. See, this says surface area. This one says volume. Volume is much easier. Volume talks about space. How much space would this guy take up? So that means all you have to do is count the actual cubes. Now be careful. Here, it's missing a cube, right? So we don't want to add one where there is not one. However, underneath this guy, like in this back corner, is a cube that we can't see. We know it's there, but we can't see it. So we do need to add that one. So I would say, let's count them up. I would say we have 1, 2, 3, 4. This cube makes 5. Let's count the ones we can see. 6, 7, 8, and then don't forget there's a cube back here that's holding these guys up that we can't see, and that makes 9. So if I did it right, we should have 9. We're not counting faces, we're counting the actual cubes. So let's see if I got this right. Do we have 9 at the bottom? Hey, look at that, it's C again. Right there. There's our answer. Okay? So again, this is a good way to be able to show me your work, is just to write down the numbers of all the cubes. So volume, you count the cubes because we're talking space it takes up. Surface area, you count the faces because we're talking how much do we have to cover. Okay, so we've got 1 through 4 done. Now let's look at the back side of your paper, the second one. And this one, number 5, gives us 3 two-dimensional views. We have the front, the top, and the side, and we need to match it up with a 3-dimensional figure that's already drawn. So let's see what we have here. Our front view needs to have 4 across the bottom, and then 1, 2, 3 going up this second column. So 4 across the bottom. I've got 4 here, 4 here, 4 here. Look, I've only got 3 in D, so that I'm going to get rid of right away. Okay? I'm going to see something. I'm going to try and make this a little smaller so that, there it is. So maybe we can see it all at once. So just for this, I'm going to make it a little smaller. And we're going to clear out what I've done. Okay, let's try this. So we've said that we needed 1, 2, 3, 4 across the bottom, and all of them have 4 across the bottom except for D, so that's the one we're going to get rid of. Then we said that our second column needs to be 1, 2, 3 high. So I have 1, 2, 3. I have 3 here, but it's in the third spot. See that third column? So I'm going to cancel that out. So right now I have 3 here, and I have 3 here. My top has 4 going across, so if I look at my top pieces, I have 4 there, and I have 4 there, so my top isn't really going to help me. So now let's look at the side. If I turn it around to the side, I have 1, 2, 3, 1, 2, 3. So what am I missing? Well, now if I go back up to this front view, look right here. I don't have anything right here, but in letter A, my front view, it has this extra cube. Since it's missing here, it should not be here. So that's how I'm going to cancel that one out. So there's your answer. Does that make sense? First, look at the front view. Make sure it matches. Then the top, and then the side. All right. Let's clear this out and look at see what number 6 says. All right, I bet I can make this bigger again so it's easier for you guys to see. Okay, so number 6, we're going to, I'm going to talk, so you have to listen. It says list one reason why each field would need different views. So what kind of view would a scientist need? And remember, our PowerPoint, we talked about a scientist needing to see sections of things, right? So maybe a scientist would need to take, if you remember, I do have the PowerPoint pulled up over here. So if you remember when we were talking about this, right, we were saying up here, a scientist or a doctor would need sectional views of the human body. So they would need slices or side pieces of it to be able to see the different layers. So anything like that would be good for this one. Just one reason. They would need to see, the skin, the muscles, the bone. They would need to see the sections. An architect, again, we talked about the architect as well. If we come up a little bit higher here, the architect. So if I'm an architect, am I really going to want to see the top? No, I'm probably going to want to see a front or a side view of a building to know how tall is it, how long or how wide is it, how far back does it go, anything to see this, how it's made. Architects build things. So how is this made? So again, just write something down, one reason why a scientist would need different views and why an architect might need different views. All right, number 7, match the letter above to its correct name. So A, B, or C, which one is the face? Hopefully you picked B. Very good. We'll come over here and we'll mark B is the face. And the edge, remember the edge is where two faces come together and they make that edge right there, that line. So the edge is going to be C. And a vertex is kind of hard, but the vertex is the point where you have lots of edges coming together. Okay, lots of faces and edges coming together, and that makes a vertex. So your vertex is going to be A. That's pretty easy. Okay. Now let's see here if we clear this out, and let's go down to number 8. Tell if the shapes below are 3-dimensional or 2-dimensional. So remember we talked about what's the major difference between 3 dimensions and 2 dimensions. In 3 dimensions you can see depth, right, that you cannot see if it's just 2 dimensions. So a circle, just a flat circle, would be 2-dimensional. So let's write this for you. This would be 2-dimensional. However, a cylinder, right, that's going to be 3-dimensional. If I wanted to find the surface area or volume, how much space this fills, I would need to use a 3-dimensional formula. I need something that talks about the area of how big the circle is, but also about the height, because it's 3 dimensions. Whereas if I wanted to find the area of the circle, I would just do the area. I wouldn't need a height because there is no height. This right here is called a rectangular prism, and it's a prism because it's 3-dimensional. It has a length, a width, and a height. And hopefully you remember some of this from last year's class, a length, a width, and a height. And finally, this is 1, 2, 3, 4, 5, 6. This is called a hexagon. 6 sides, it's a hexagon. It's flat, so it's going to be 2-dimensional. And just so you know, you can have a hexagonal prism. And that's a 3-dimensional where you would come off and you would have the depth of the hexagon. Okay, so there's number 8 for you. Let's clear this out. And finally, let's see here, we have number 9. What one word can be used to describe a 3-dimensional figure but not a 2-dimensional figure? Length, width or depth, height, measurable. Well, they all can be measured, so we know it's not that one. They all have a length. And to be honest, I would give you either B or C as an answer, because I think in this one what the person who made this worksheet is going for is the depth, right, going back. Although when we talk about a regular, just a square or a rectangle, we say length and width. So if you wanted to put height, that's also a type of depth. But I think what they're going for is B. I would give you credit for either one. That's all there is to this worksheet. If you guys can do this on your own without my help, then you have got this concept mastered, and I have no worries for your test. Ask if you have any questions. Thanks, guys.